Fantastic. Okay, so it's 2 minutes past, so we should probably get started. Hi, everybody. Welcome to another weekly episode of YFTT, a talk for engineers by engineers. This week, we're going to be talking about Voyager, the new product we just announced. I have here with me Prasad Radhakrishnan, who is a product manager who is, among other things, one of the things he's been involved in is with Voyager. I'll let him do the intro, but just a couple of logistical things. If you guys have questions, or even want to say hi, which we really like, please feel free to put it right in the LinkedIn event comments. And you can also connect with us and Prasad and other engineers. Everybody will be looking at our community Slack as well. So yugabyte.com/community, and you can just go to the YFTT channel or just post in the YB users channel. Okay, so let's kick it off with that. So Prasad, do you want to do like a minute intro and we can get started?
Sure. Yeah, so I'm Prasad Radhakrishnan. I'm from the product team. So there are, quite a few products and initiatives at Yugabyte, that I am part of. And one such a thing is Voyager. To me, it is a very exciting product to be, to have been part of in the development and the launch of Voyager, and it plays a very critical role, which I'll cover, in my set of slides. So that's it. Is this a good time, Karthik, for me to, start flashing a few slides that I had prepared?
Yeah. I think the first question everybody's thinking is, what the hell is Voyager? So maybe you can start there.
Okay, so I think, see, every product, we consume a lot of products in our lives, right? All the way from, whatever for, regular, like, Word and Google Sheets and so on to, other very sophisticated products as well. But one thing that usually when a new product is presented, the question that comes, people's mind is, wait, what's the motivation? Why did you even, come up with this product? Why did you create it, right? So let's look at the motivation before I dive into, what is Voyager. I want to take some time to articulate the motivation, right? So the motivation is simple. To me, there's one word that sort of explains what the motivation is. It is to modernize, right? A lot of enterprises, are having initiatives. I think some of the analysts say that there's huge budget that gets allocated for digital transformation and modernization initiatives, as we all know. Usually some of the characteristics or the reasons that folks would want to get rid of legacy and move to something more modern is I just came up with a few things that is very common. Higher total cost of ownership, it's expensive, it doesn't scale, the performance and the business needs are evolving, and the legacy systems are quite unable to sort of catch up or meet with the evolving needs, and there are a bunch of other reasons, right? So then they undergo this effort, which is often called modernization, right, as a verb, to modernize, right? And then then the systems, that are once modernized, or bringing up a few value propositions that include the apps are now cloud native. The TCO is lower. And because they're cloud native apps, you also get to configure your own TCO, right? Like depending on how you scale and where all you deploy and so on, you get to configure it. And they often, are capable of scaling on demand and brings better performance, higher performance. There is agility and a ton of other benefits, right? Now usually modernization is, I want to say, heavy footed towards, application modernization. But folks who really do modernization, have been part of such initiatives, know that it's incomplete, or actually a good chunk of modernization effort is also to modernize your data and databases. Right now, the equivalent on the database and the data side, specifically on the transactional databases, right? Now, on the left side, you can see that legacy databases, what people have come to realization is that it's expensive. The licensing model is super expensive. It's proprietary technology most of the times, like, Oracle and SQL servers, doesn't scale. It's not a distributed system, by design. Sometimes even if they are open source, they are tied to a specific cloud provider. There are nuances to it, and you're not able to, untie yourself when needed. And it doesn't meet, evolving security and compliance needs. Like, you may have GDPR and other requirements to think that, you could implement that using legacy databases. It's almost close to impossible. So there are a bunch of reasons why, as part of the modernization journey, the legacy databases, also get modernized. And often, we are in the midst of helping our customers, to be able to modernize, their data layer over to Yugabyte database. Now, some of the value propositions, not the exhaustive list. It's like, for a start, Yugabyte, as you folks might already know, it's a cloud native database. It brings distributed SQL. It's lower, TCO, and it's also completely, a kosher, Apache license open source project, right? So there is a community edition, which is just as powerful as the commercial edition, and it scales horizontally, vertically, and better performance. Most importantly, it's Postgres compatible and ton of other benefits, right? I don't want to, spend a lot of time, on that front, but to highlight now, when you try to modernize, right, often modernization from legacy to Yugabyte involves migration, right? You will have to migrate in order to, get to, Yugabyte. Now, so I think the point that I'm trying to strike here is, in order to, modernize your systems in totality, it also involves migrating to a cloud native database, right? Like YugabyteDB.
Yep.
Now, that is the core motivation. Now understood, right? I think everyone would be able to agree with, hey, I see what the motivation is. Now, let's look at, typically what happens when you try to do data migration, right? So there is often a source, often a target, right? Now, there is something in the middle that takes care of, pulling data from the source, schema objects and all of that, and pushing it to the target, right? And you can call it can be a migration tool that's out there, or it is a bunch of scripts that you might write. It could be any of those combinations, right? I think that's what the slide actually captures. You connect to the source, you export schema, you export data files, and then some tools can also capture change data. And if your tool doesn't, good luck to you, because often, once you're done with the migration, there's still data falling in the source, and you got to figure out how you're going to move it to the target, right? Now, what's the catch?
I think the complexity is also that the tool for a given database, for a given feature set, like if you want, change capture or not, or all of that is very fragmented, right? At least what I've seen, you need a lot of knowledge to know which tool to pick for which scenario, right? So.
Agreed, 100%. They're usually, heavily leaning towards one kind of a source database that they know how to migrate over to target. Yeah, I agree.
And so the other issue is, if you're going into the cloud, it needs to work with, like, an S3, etc. But anyway, yeah, perhaps you're probably going to cover that. So I'll just keep quiet.
Yeah, I mean, so now to give credit to these migration tools that are out there, right? They do actually work really, really well. If the target is going to be yet another, monolithic or single node database, could be MySQL or, Postgres, it works really well, because single node, monolithic, there's not a huge difference. Maybe, there's other benefits why you move to Postgres, but, it's going to work just fine. But if on the other end, you are migrating over to a distributed database, the migration tool often doesn't really understand, what are the strengths of the target system? How does it scale? How does it handle connections? Can I spawn, how many number of connections? It doesn't have that kind of intelligence. So that is a huge drawback, because that falls upon the end user then to figure out, okay, I'm going to install this 10 times, I'm going to install this 20 times, and I'm going to. Then it's almost like client-side sharding. The user has to now take care of all the other things. And then some tools which are still capable of working with a distributed database like Cassandra and so on, they have heavy dependency on some of the monolithic systems like Hadoop or a distributed computational infrastructure. So you could now generate SS tables or whatnot and shove it to the other end, right? So there is dependency. So pretty much, there is no consistency that is brought to the equation when it comes to migration, right?
Yep.
So, now all this put together, now on our end, the onus was on Yugabyte, to figure out, hey, how do we now, provide our consumers, users with a very effective migration tool that really works with a distributed SQL database, right? So that said, let me cover some of the requirements, that we had come up with initially for this product, to be taken into consideration. So there are obviously, simple or the most obvious requirements. Like, hey, I want to do offline migration, and I want to also be able to do online migration, right? The offline migration involves, export source database schema objects, whatever that is, like, tables, indexes, stored procedures, functions, all of that. I want to be able to export it. I want to generate a report so that, before I start importing, users can verify, and then to be able to create the schema objects on Yugabyte, and then, find a way to bulk load it, or, load it as fast as you can. And then, at the end, be able to do validation and generate a final report. So the user can, walk away with some confidence, how the migration went and so on, right? That's about offline migration. The online migration is all of offline migration, plus to be able to, detect change data after, we took a cut, there is still data, falling on the source database. I want to be able to stream it over to the target Yugabyte cluster. Offline, online, I think that's, often well understood. But we also want to take into consideration, a failback option, right? Interchangeable failback, fallback, however you want to call it. So basically, to be able to say that, hey, yes, we did replicate everything over to Yugabyte, but for whatever reason, I want to fall back. My apps are, doing a failback. So I want to make sure, my database is also doing a failback, whatever the crazy reasons might be. We still want to provide the users with an option to be able to fail back. So, some of the perceived risks can be mitigated. Right?
Yeah, this comes up quite a bit, sometimes completely unrelated to database, because sometimes the migrate to environment is a public cloud from a private data center. And, it takes a few months, years, whatever, to get the operational expertise. So having a failback is actually a good thing. So you can come back to the way things worked while you increasingly build maturity on the other side.
Absolutely, yes. But it doesn't end here. We had a whole bunch of other things to list, and, I just put it all out, in this one small box, but broadly speaking, these are bucketed under, user experience, scale, performance, and so on. But to just, read few of the important ones out, we want to make sure there's a user-friendly CLI, because, you provide an amazing CLI, there are a bunch of automation and stuff that you can do on top of it. If any automation has to be, developed on top, there is that. And we want to ensure that, look, source files could, be very huge. We want, there are advantages to chunking it. So you could send chunks at a time to Yugabyte, because it is a distributed database. It scales horizontally, vertically, and so on. You want to, make sure the cluster is at a, top utilization. Like, you want to push the cluster over to 80, 90% utilization, for which, we wanted to be able to, effectively chunk the source files. And then, we wanted to parallel ingest the data, obviously, it goes without saying. And we want this utility to understand, hey, for the given cluster configuration, how am I going to, parallel ingest it? You would do this differently for a 3-node Yugabyte cluster versus a 30-node Yugabyte cluster. You could pump more at a faster pace with a 30-node, obviously, than with a 3-node. But we want this utility, this product, to understand that, based on the cluster configuration. And then we wanted to have consistency, as in, it could be Oracle, it could be SQL Server. And tomorrow we could end up supporting, migration from DB2 and several other legacy databases that are out there, or simply from flat files. But we wanted a consistent, interface in the middle, regardless of the varieties of, legacy database that are out there. That was a straight up, requirement that we took into consideration. And we wanted safe defaults. I think I covered this already, but to just, reinforce that point, number of connections, batch size. If it is the right thing to do, let's disable transaction mode, let's enable upsert mode. There are certain things you want to do when you're trying to, do a bulk load of data. So we want this, product to take all of that into consideration. And we want, importantly, anyone who has worked on, data projects know that item potency is something super nice to have. It's hard to accomplish, but it's, we took that into consideration that, hey, same file, if I ingested it again by mistake or even intentionally, we should ensure that, it doesn't screw up the data or the number of rows on the target Yugabyte cluster. And also to be able to restart or resume often when you're doing a large scale data migration, it's inevitable that you're going to bump into some issue, like ill-formatted string, or there is some weird character set, bunch of reasons why a data load could fail. But we wanted to be able to, restart or resume from where it failed and not go all the way back to the starting point and run the whole run again, right? So these are the things taken into consideration. The product does meet, most of the requirements, actually all of the requirements that I have listed there on the right side, right?
Yeah.
And before we switch on to demo, I want to really run fast here. I think I'm eating too much of time. I want to make sure, demo is where we spend a lot of time. I just wanted to cover at least, offline migration, what is the process flow? How does it work? Phase one is prepare. So Voyager is a product that you would install in a VM. You want to ensure that there is sufficient disk space in the VM because we do export data and we store it temporarily in that VM. With regards to system requirements and so on, we have, listed all of that in the docs, which I'll share the link at the very end. And then prepare the source DB, prepare the target DB, which is nothing but ensure that you got the connectivity, you got the right level of access to do what you want to do, right? So that's kind of the prepare phase. Now let's get into the second phase where, it's about migrating the schema. So the first step, obviously, connect to the source, export schema, right? So there are very user-friendly CLI commands to export schema and objects, which includes tables, views, stored procedure functions, triggers, indexes, sequences, and I'm missing, a bunch of other things. All of that, its DDL is exported, right? And what we also do is, for stored procedures and functions, a translation to Postgres compatible syntax does happen, in this phase, right? Now, the second one is analyze schema. So when you are any migration from A to B, often, involves some kind of an inspection. You want to check and you want to tap into certain, superior features that are available on the target Yugabyte side, with regards how you distribute or, some of the other tweaks you want to make to the DDL. You could, tweak that before the next phase, which is, import schema that gets triggered, where in this step, we apply, all the DDLs or we apply, the schema over to the target Yugabyte database. Again, here, one thing I want to mention, some safe defaults kick in and the safe defaults can obviously be overridden. For instance, one thing to mention here is one of the good practices, out there is that, hey, if there are indexes, when you do data load, just defer it for the last phase, as finish the data load and then create the index, right? It just speeds up the data load. So such defaults are already in place. And one other thing to highlight is, triggers are created but disabled. Foreign keys or foreign key check is disabled as well. And there are a bunch of other things. I just want to highlight a few, right? Rushing past to the third phase or the final phase here is migrate data. So obviously now we export the schema and then we import it, and then we are going to export the data. So what we do is from the source database, how many tables are there? We're going to export flat files out and sort of store it in the Voyager VM. And over there, again, there are some safe defaults that kick in. As in, we figured based on tests that, hey, let these files have 100,000 rows or less. We don't want to, so that we could, send one file at a time over to Yugabyte. So you could override it again, but if you didn't say anything, it's 100,000 rows per file. Those are named in a certain way and stored in a specific folder structure that Voyager understands. So it goes, a few files at a time to load it, right? And then the next phase is, import data. So safe default over there is if I have a 3-node Yugabyte cluster or a 10-node Yugabyte cluster, we will spawn one connection per data node. And then we disable transaction mode, upsert is enabled, foreign key check is disabled, all those safe defaults kick in. And then, bulk load begins where we are pumping, 100,000 rows, whatever is there in that file, we pump it and then we are tracking progress file by file or chunk by chunk, right? And if, like I mentioned early on, if there are any failures, we will start or resume from, where the failure happened after, the remedy steps are, taken, right? So that is the import data phase. And finally, verify is, to be able to just do, we usually print, even in the interim, how many rows were in the source table, how many we imported. So the numbers tally up on the left side and right side, so you can feel confident about migration, right? That said, I'm gonna pause here, and I'm gonna turn this over to Jamin here. We do have a demo of a very simple, a demo where there's Oracle database, and we are using Voyager to be able to migrate the schema and data and stored procedures over to a target Yugabyte database. So Jamin.
So as you're handing over to Jamin, Jamin, maybe you get set up. But there's a question, Prasad, which is from Nikhil.
Yeah.
And thanks for the question, Nikhil, which is he's curious to know how YB Voyager compares to Kafka Connect framework for transferring data between source and sink. Wouldn't that open the doors for migrating data to a wider set of data stores?
I see. So I think, now it's about the nuances, of Yugabyte database, how that gets factored in a very standardized way, right? So the reason for us to have this as a separate product is so, we are able to bring a consistent interface. Now, the Kafka Connect route, obviously, the consistency is going to be, you got to do it either in the way you are sourcing it or in the way you are syncing it to the target, right? Now, and then the nuances between Oracle to DB2 to SQL Server, all of that every time has to be thought through. But here we want to completely eliminate, that concern from the user, because man in the middle, which is YB Voyager, brings the consistency and understands the nuance of the source and takes care of all of that without the user having to intervene.
And the Kafka Connect framework is just for the online migration piece, right? There's still the schema conversion. There's still a lot of other pieces that we're wrapping in this. I at least based on your presentation, that's what I get, right? So hopefully that answers the question, Nikhil. Yeah, feel free to go ahead, Jim. And if you could increase your font size, that's great. I think most people can see, but I just like having big fonts just in case. If not, it's okay. Don't worry about it.
Yeah. Sorry, Karthik, I'll try, but no
worries. No, so this is fine.
So we are going to migrate Oracle 11.2.0.4 to Yugabyte version 2.15. That's the latest version we have. And in the first step, we are going to migrate the schema objects as Prasad and Karthik talked about in a few minutes back. So let's kickstart the YB. We are migrating, we are exporting all the objects like a type, sequence, table, procedure, functions, triggers in the first step, and let's wait till complete.
Cool. So this is the phase where Voyager simply connects with the source database. Here it happens to be Oracle. And you can see whatever objects are there that are relevant and often falls in the scope of migration. It gets exported, and then it's available for a review or validation before it gets applied, over to the target Yugabyte database.
Fantastic.
And just want to add what Karthik said and Prasad said, like the Kafka will not do the migration for the schema objects or code conversion. That is where the YB Voyager comes into the picture.
All right.
The second step.
Yeah. First step done.
The second step, we are going to analyze how many objects we can migrate. If there are any issues with any of the objects, we can see something called in the second phase of the process, and we generate the report. It tells us how many objects can be migrated, and if something it's not migrated, what needs to be done. Like this particular package, we cannot migrate. Okay, so we need to do, or we have to work it out. Manual intervention is required here in order to fix that issue. Okay. So far we have seen like 13 tables, 20 indexes, 2 packages. Out of 2 packages, one is like we cannot migrate. 16 views we can migrate out of the box. 8 procedures, no issue, we are going to migrate. Okay. Now we have already fixed certain things. So in order, I'll just run through the or update the fix and rerun the assessment report in order to show them.
Okay, so here you're making the fix, right, for something that was not supported.
Yes, correct. Okay. And we reanalyze we rerun the assessment report, and we can find out the difference. And we eliminated all the issues. Okay, so we can see here there was a problem. Now it's all clean migration report. The next step is we are going to do the import the schema in Yugabyte cluster. So here I'm stopping for a few seconds. So we need to create the prerequisite. We required target database to be created. Okay. We also required schema, generally multiple options available. Public schema, it's by default created when you create the database on the target side. But let's say if you want to keep the consistency from source to target, in that case, you can recreate or you can provide the schema option with the YB Voyager. So what it does, it will create the target schema also along with the with the objects.
Okay, so while that's going on, a bunch of questions are starting up. Yeah. So I'll start asking one by one. Any specific reason to select the source DB as 11204 Oracle? It's not supported. That's what Amit Kumar says.
There is no specific reason. I think we simply wanted to pick an Oracle database.
I thought it was to show how much old we support, because Jamin kept us. It not only supports 12, go down to 11. He's been pushing us, so I think it's mainly that, but no specific reason. Yeah.
Yeah, just adding the Oracle 11.2.0.4. It's the best release from the Oracle so far in the history of Oracle, and there are so many, still so many. Projects are using the Oracle 11.2.0.4 in production, even though it's no longer supported. So we just wanted to make sure that we can go like a 1 decade back to get migration. So we have created all the objects on the target Yugabyte database cluster. Now we are going to kick off the data export from Oracle and put it in the flat file. That is what Prasad explained in the previous slides.
Okay, I think while that's happening, Kavya has a question, which is, since having primary key on tables is critical to YugabyteDB performance, does Voyager report tables that might not have PK in some source DB? These tables likely could have unique index defined on them rather than as PK.
Right. So generally speaking, when there is no primary key defined on a table in Yugabyte, there is a PK that gets assigned internally.
Row ID, yeah.
Row ID. So there is a PK that gets assigned. Now, with regards to unique index, so that is something, as a best practice, that is deferred to the final phase. So when we do the import schema, we wouldn't be creating indexes at that point, and that would kick in later.
Also, Kavya, a lot of these catches will go to a performance advisor type thing where it will watch the workload and tell you, look, this has to change, that has to change. But it's a good idea. We can put some of these as warnings in this process also. It's fine. Hey, we might just want to take a look at this at the expense of there being a lot of such warnings, but yeah, it's still worth thinking about. So maybe this is something we could add to our list of how we detect transformations.
Sure.
Yep.
Yeah. Okay. Yeah, let's keep going.
Data migration is like a data export is completed. Now we are going to import the data to the target Yugabyte cluster. And here we go. So first because table is already present, so it goes and truncate because we are using the start clean. And let's say you want to do multiple iterations for import data. So every time it truncates the data and perform the data import. All the tables are imported now. So we already resumed the value for the sequences. And now we are creating the indexes. And if there are any triggers, we are going to enable the triggers at this point. That is what Prasad already covered in previous section. That is all done, safe, already taken place in order to improve the performance of the migration process.
Fantastic. So
Nice.
as we wait for that, another question. This is Amit Kumar. Are we able to connect multi-tenant architecture for Oracle?
Yes, we do.
Yeah.
Yes, we do.
Awesome. Fantastic. I don't even know what that is, but great. Somebody knows.
Yeah, I was not able to quite decipher what the question is, but okay. I think it's a very Oracle specific question, not a deep expert, but okay.
Yeah, we can connect to very specific to the PDBs. That's called multi-tenant architecture starting from 12C.
Oh, it's the PDB. Got it.
Yeah.
Terrific. Well, a couple of more questions, I think, Karthik.
Yes, I was waiting to see if there was. Yeah, I think we can start. Yeah, the next question also. So I think there's another question from Kurt, who says, this is a cool migration tool, but as you know, another big related problem is converting applications to work with YugabyteDB instead of the source DB. Have you considered making a compatibility translation layer to address that?
Wow, that's actually a very deep and a tricky question, right?
Yeah.
Because it really is going to depend on how the source database, what kind of ORMs were used and the choice of the programming language. I mean, they're interrelated and so on. So at the moment, I don't know if there is actually, a sort of a solution or approach that we could cohesively sort of put in place, right, for the different nuances that might be out there on the application side. But generally speaking, if your apps were designed for an era where it was dependent on ANSI SQL, and it could seamlessly switch over to Postgres compatible database technology, then the migration becomes a lot simpler.
Yeah, I think also, Kurt, the other aspect where we thought about this long and hard is that we want, like, without the code, I think it's almost a flat out assertion that we've come to, that it's going to be next to impossible to truly emulate the database, the source database, whatever you're impersonating. I mean, it's possible to do it from a translation / support increasing amount of stuff perspective, but it's going to be difficult to do that from a transaction compatibility, or increasingly the app should behave as it does in edge cases. So that's why we stuck to Postgres. And perhaps MySQL is something we can consider because the source code is also open. But with Oracle, I think one of the things that we're thinking about is we'll probably go like with some of the open source tools that are trying to emulate Oracle, like Ora2PG, which we support, or there's more and more coming up there. Same thing with Babelfish. But these are long projects where you keep increasing the percentage of coverage and similarity to the source database. So that's why we focus more on. So in other words, we're helping people get to a Postgres cloud native architecture with all of the relational support and the best tool set available to convert. We're not so much focused on truly emulating Oracle at what it does, because we believe that it's a trickier road to complete, right? That's, at least it's a philosophical at the end point of view, right? And based more on our observations of what users and customers want from cloud native.
So right now,
if the source app is in Postgres, then by using smart drivers, one can easily take advantage of the distributed architecture of YugabyteDB.
That's right. Yeah. So that's the thing, right? It comes down to cloud native application architecture versus lift and shift from Oracle. Like we are more on the cloud native architecture, and we're doing all of this to make it easier to move as opposed to truly support that as a migration. Because the question is then what, right? Is that the permanent state or is that just a temporary state?
Yeah, so data got imported now, and we can do the basic validation check. Let me stop sharing and bring up the other screen. So we have an Oracle here. You can see on the screen. I'll just make it so we can do the comparison side by side with Oracle and Yugabyte. So I'm going to run a couple of queries on the Oracle side. One is the table, another. One is the table. The second one is it's a view. So we have a 779 records for the table, order tables, and we have an invoice. That's a view. That's a 1686 records on the source side. We are going to run the same queries on the target side. And we can see that we have same number of records for source and target. I'm going to run the procedure because we already migrated the procedure from Oracle to Yugabyte, and we can run the same procedure on the source, and we can run the same procedure on the target to compare the result set. Okay, so I'm running the stored procedure on the source side, running the same stored procedure on the target side to compare the result set. So you can see here we have like a 13 records and same number of records. You can see on the left side that's a Yugabyte, right side it's Oracle. So you can see we have in the same order.
Yeah. And can you show me the procedure call differences between the two? I was curious how it looks.
Yeah, so this is the procedure call.
No, what I meant is the invocation, right? Like I think in Postgres, I can see it's call nw.cust order hist something. How does it look like in Oracle? Like, can you show me those two side by side?
It's been exec.
The exact call. Yeah. I think you had it in your notes, right? Where you cut pasted from. Maybe we just go to that.
I think how do you run the proc?
So this is the call. Okay, this is the procedure call where you can see we are calling the cust order hist, and it is returning the ref cursor. Okay, and we are looping through the ref cursor, and all the records are printed on the screen.
Okay.
Just cross validate the output. Okay, in Postgres, sorry, on Yugabyte, it is done in the steps. We are calling the procedure. We are fetching all the records from the ref cursor and automatically printing here. It is okay. That is how it works.
Fantastic.
And just wanted to add here. Want to show something else also. So we can see all the objects on the Yugabyte side. We have all the list of tables and view. On the bottom part, we can see all the procedures got migrated, and whatever one package that is now part of the procedure, because Yugabyte does not support the package concept, but we convert the package into schema.procedure. So there are multiple options available. You can create a package as a schema, and within that schema you can create the procedure. So you can call same package.procedure the way you call it in Oracle. Okay, and to make it simple example, we created everything, all the objects under one schema, so we do not have to manage multiple schemas. Options are available.
Got it. Fantastic. Yeah, fantastic. Awesome. That was a great demo. Yeah, that was fantastic. Anything else that you have for us, Jamin?
No, that's it. But open for any questions.
I think we are good on the questions. So maybe right before we close, we'll do a couple of minutes. So one question for you, Jamin, which is how does this, like you've done a lot of migrations, right? How does this simplify in your words? What do you think this does for you? Just maybe a minute or so, right? So
this tool helps us to automate a lot of things in the schema migration, because that's a tedious task. It's not easy for a heterogeneous migration from legacy to the new modern stuff. Okay, and we are bringing the gap, or we are creating a tools which helps reading from the old and writing to the new one, and it saves a lot of time for developer side. We are also providing analysis or assessment reports, so you can determine which objects can be migrated or cannot be migrated, and where you need to focus. Okay, that
awesome.
is most important task for a developer perspective.
Fantastic. Fantastic. And Prasad, what's on the horizon for Voyager? This is just the beginning, right? As I understand.
Right. No, we want to be able to support, a variety of, like, let's say, integration, not integration, like, to be able to directly, consume data off of S3, right? Right now, we are, just, storing data in the local, but more, in a very cloud environment, air quotes. You often want to use S3 as your, sort of the place where, you drop something and pick it up, and then you purge it. So there is that. And then, and we want to also get more advanced and sophisticated with Oracle stored procedure migration. It's actually, a very deeper and complicated and a very gnarly kind of scenario typically, right? There are, like people have developed stored procedures over 10 years, it has, evolved, and there are complicated scenarios with procedures that, we want to, spend more engineering cycles to simplify. So there's that coming up. And obviously there are, pent up demands to say, hey, can you actually directly go to, DB2? I have a lot of stuff in mainframe, DB2, and could you, help with migration? Now, at least we have a temporary solution, which is like, as long as data comes out of DB2 over to a flat file, then we can, pick it up from there and take it to Yugabyte. There is a, interim solution, but to be able to directly latch on to different other variety of source databases, those are, some of the high level, roadmap items.
Awesome. So fantastic. So I think just a bunch of kudos for you guys. So Kurt says, it was a great job, Prasad and team. So he really enjoyed it. Todd says, thanks all. Looking forward to trying this in a POC. Todd, yeah, we'd love to work with you to see how it goes. Nikhil said, enjoyed the session. Please keep sharing the good work. So yeah, thanks everybody. This is fantastic. Your support keeps it going. Yeah, so that's it for this week. Join us next week for another session, same place, same time. And if you have questions, once again, drop it in the LinkedIn channel. Everybody in the LinkedIn chat, everybody's monitoring it. And you can also join our community Slack, yugabyte.com/Slack, and just post it there. We'll get back to you. If you have suggestions, we'd love to hear, because this is just the beginning, right? Like as Prasad was saying, a lot more interesting things. Once again, thanks everybody. Have a great Friday.